I'm going to go over this example of using the square root property. The square root property allows us to solve quadratic equations without having to factor. And our goal, and in order to use the square root property, what we need is my very simple explanation over here that says on the left-hand side we need something squared. We need some grouping squared, and on the other side we need to have numbers. And what I mean by that is we need to have a quantity or a variable, something, some grouping, and the only thing on the left-hand side is being raised to a power of 2. And the only thing on the right-hand side are numbers. We don't have any variables, so we can't have x's on both sides and expect to use the square root property and have this work out. So in this problem, this is one of the simpler examples here. We have on the left-hand side, we already have this grouping raised to the second power. So what I want to do is add 6 to both sides so I can get this grouping 2x, we can get 2x minus 4. This quantity squared, we'll get it by itself, and this is going to equal minus 2. Now we can take the square root of both sides. On the left-hand side, we have the square root. We can take the square root of that square, and we can take the square root of the right-hand side. And what we get is, well, the square root of a squared term will be absolute value of 2x plus 4. But remember, we can, instead of writing absolute value every time, we can just write a plus or minus over here. And the square root of negative 2, well, I'm going to leave that the square root of negative 2 for now. I'm not going to try to simplify all in one. I'll just write it like that now, and then that'll allow you time to look at it for a second and see that we can actually, since it's minus 2, we can write this as I root 2. Now what I want to do is just solve for x. So I'll add 4 to both sides. I'll get 2x equal to 4 plus or minus I root 2. And I have to write it like that because I cannot combine the 4 and the I root 2. And now finally, if I divide both sides by 2, I'll get x equal to, well, I have 4 plus or minus I root 2 all over 2. Since this is a complex number, we need to break it into its real parts and its imaginary parts. So I'm going to write this as, well, since they're over the same denominator, I can write this as 4 over 2 plus or minus I root 2 over 2, which simplifies to 2 plus or minus I root 2 over 2. And that is how you do this. And again, we need something squared. And once we have that, we isolate it, so move the 6 to the other side. Take the square root. Remember, when you take the square root of something squared, we have, eliminates the square root in the square, but then over here we have to have plus or minus. Then we simplify this, making sure we remember all of our rules involving simplifying radicals, and then we solve for x. And remember at the end, when we have something, it's better to break it apart into its components like this as opposed to leaving it as one big expression.